Great, thank you. And it's awesome going right after Shuvi because she covered all the scheduling for the JavaScript and processing side of things, and now I'm going to kind of go a layer deeper and talk about the fetching and the resource prioritization and the network layer side of things. So in my world, it really kind of boils down to, I have kind of a myopic view of the browser and the things I care about as far as what drives the user experience from a fetching resources perspective. And so rendering, the browsers, they all do it these days. They incrementally paint opportunistically. When it thinks it's going to be waiting for a long time for things to happen and it has things available, it'll go ahead and try and draw what it has. But there's nothing that the browser has to draw until it reaches the body. Right? There is no DOM, there is no document, there is nothing to draw on the screen until the browser reaches the body. So a lot of what I pay attention to tends to be what does it take for the browser to be able to get to the body to reach that first paint. And this all sort of assumes kind of maybe old school HTML. If you're doing client rendered apps, I'm sorry. But then it's all in your own hands, right? It's way much later. It's whenever your JavaScript builds the client DOM that the browser's then going to render. And you have all the control, but also all of the responsibility for when that happens. And so there's some very, very basic rules about the browser's main parser that prevent it from getting to the body. And these are, all browsers have to do this. These are spec musts. And so the script tags, for the most part, are the key thing to watch out for. And for those, it's non-async, non-defer scripts. Both inline or external scripts are sort of the key blockers that cause the main parser to just completely stop and freak out and wait. And whenever they reach a script tag, if there's any CSS that is needed for the document, that's like not print CSS, anything that matches the document style, it has to stop and wait for that CSS to finish downloading and being processed before it can do anything with the script tag. And so it stops and waits. And then it also has to wait for the script code itself to have downloaded, parsed, and execute before the parser can go any further. And so it does not pause for CSS itself until it gets to the next script tag. And so this is where you start getting into the sort of tips and tricks of, okay, maybe you can put your inline scripts before your style sheets so that you're not blocking for the CSS to finish loading before it can get to the body and do the DOM, because you can parse the JavaScript, start loading the CSS, but keep going while it's still loading the CSS. It also doesn't care about images for the most part. It won't stop for them. It'll notice that they're there. It'll take note of it, and it'll just keep going. And so we kind of tend to optimize for how quickly can we get the parser to the end of the document. Time to first contentful paint is pretty much how quickly can we get the parser to the body, and DOM content loaded is pretty much how quickly can we get the parser to the end of the document. And those are sort of the two main metrics we would always optimize when I was at Chrome working on the browser, and pretty much in those order. We want to get something rendered on the screen, and then we want to get the document built as quickly as possible, and then go on and do all of the fetching of images and everything else. The resources it needs, it can only fetch them once it knows about them. It's probably not a surprise. But we've got the main parser. We've sort of learned when it stops, when it pauses, what freaks it out. And it's really just those simple rules. It pretty much only stops for script tags and under certain conditions. But when it stops, there's a preload scanner that will tear through the rest of the HTML looking for anything that it thinks it might need and start prefetching those as well, or at least queuing them and becoming aware of them. And it looks for style sheets, scripts, anything, excuse me, anything later in the document. And we've got some rules in there as well where we can recognize a script looks like it's before the body or early in the document, it's going to be an important script. It's a script later in the document, it's going to be a less important script. It's a script that has an async tag on it, doesn't block us, we don't care. And so that's where we start to get into things with the prioritization, where what the browser thinks about things may not be necessarily what you think about things, right? It's just because it's async and doesn't block the parser, now all of a sudden the browser's like, woohoo, I don't give a crap about that script anymore, it's not blocking me. Whereas you're like, woohoo, this is my script, I still really care about it, I still really need it to load. Like for analytics is kind of one of those key ones. Analytics, it's really, really important to have your analytics as close to the head of the document as you possibly can, because once you move the analytics script down towards the end of the document, you start losing your page views, and the business starts to complain. And that's mostly because people abandoned before whatever, something was pausing earlier, you start getting sessions dropped out before the analytics can actually run. So you move your analytics script all the way to the top of the head, but now is it a blocking analytics script? Okay, you can make it async, and now all of a sudden the browser's like, woohoo, I don't care about it anymore, I'm not gonna load it soon anymore, and all of a sudden you have the same problem again. Document.write, it's sort of the classic one where the browser has no idea what you're gonna do with JavaScript, and it won't know about any of the resources you write into the page until that happens. And so resource prioritization is sort of, I kind of look at it as like nice orderly kids forming a line. You kind of get things orderly loading in sort of an agreed upon way, and it's not kind of the Wild West. If you've ever walked through Times Square in New York or tried to walk through Times Square in New York, that's how adults do it. It's completely disorganized, and that's sort of what resource prioritization is about, is trying to find out what's sort of the optimal funnel that we can get the resources loaded in and scheduled in to get as much of the user experience and the business experience up and loaded as quickly as possible. And so there is, to some extent, an optimal order for loading things. And the optimal order is probably going to be different for every application. But there are some basics that generally apply across the board. From the browser perspective, at least, we want to load the render blocking resources first. Everything that's in the head that's going to prevent anything from being displayed to the user, we want to try and get loaded and out of the way. But it also matters that we schedule them and order them one after the other sequentially for the most part. So let's say you have two scripts, let's say they take a second to download each, and they take a second to parse and evaluate each. If you download them both at the same time, you don't get both of them in a second, you get both of them in 2 seconds. And then you've got 2 seconds of parse and eval after that. So all of a sudden you've got 3 seconds until the end of, no, sorry, bad at math, 4 seconds until you've actually downloaded both of your scripts and run all of the code. Now, if instead you actually ordered them in the same way they are in the document, spend 100% of your resources on downloading the first script, you get that script in 1 second, you can start executing that script while you're downloading the next script, and you get the pipeline going. And so now you can do everything in 3 seconds, and so you shaved 1 second off just by ordering your scripts and preventing them from downloading concurrently, and sequentializing them and pipelining them so that you get to use your CPU while you're using your bandwidth instead of sort of tying everything up. After we've gotten out of the head and the render blocking resources, this is where sort of the opinion of the browser comes into play, and I can speak for Chrome because I worked on that. I'm not sure Firefox and Safari how they treat priorities once they get down into the body. But for us, pretty much blocking scripts in the body are kind of the next high priority thing that we care about, because we care about getting to DOM content loaded and build the DOM. So we'll tear through and we'll look for anything that's going to be a blocking script, load everything in sequential order as much as possible, and try and spend 100% of the time loading each one of the scripts to get to the DOM content loaded. And this kind of gets down to when you're doing your own performance metrics, what you can see is sort of the artifacts of the metrics that we use to drive the KPIs for the browser. First content full paint, DOM content loaded. These are the metrics we observe from the field. Those sort of drive the optimizations that we do. When you do your own optimizations and your own metrics, whatever performance metrics you track as a business, you're going to kind of optimize for those. So you want to kind of make sure that you're tracking metrics that actually impact what you're trying to achieve. And then after we've gotten the document built, in theory, the optimal ordering for the user would be to then asynchronously fetch everything that's user-facing as quickly as possible. You kind of want to populate all of the visible images, not necessarily one after each other. I'm kind of a progressive images fan. I know that can be kind of polarizing, but try and populate all of the images, any async or defer scripts, particularly if they're user impacting. And then after that, start prefetching your non-visible images. Yet another sort of divisive thing with lazy loaders, and do you wait for the user to scroll to see them? Do you preload them beforehand? But either way, if it's not visible to the user immediately, you probably want to schedule it until after you've gotten all of the user visible stuff on screen. And then non-user resources, your remarketing pixels, your analytics. And this, again, is, if we were looking at it from the user's perspective, this would be the optimal ordering. If you're looking at it from the business perspective, my guess is your marketing team is going to want your remarketing pixels and your analytics to be loaded really soon and really early, independent of the user experience sometimes. And so this is where we get into one of those balances and trying to figure out, okay, what is the right answer? And honestly, from the browser side of things, we can't make all of those decisions for you. And so these slides, I'll post them all online. I'll tweet out the link to the slides, but there's a link to the Chrome prioritization doc. And there's basically a giant matrix of resource type, what priority it gets, depending on where it is in the document. There is recently, Shubi mentioned it, priority hints. It's on Origin trial. You can start to influence what those prioritization decisions are that the browser makes. And you can go and say, okay, this image is my hero image, because the browser, in Chrome's case, once we get to layout and we display the images and we know where they are on the page, any image that's visible in the viewport, we're going to boost the priority and go, okay, this is a user-facing image. But we don't know about that until we get to layout. What you can do with priority hints, for example, is you can say, this is the hero image, make it an important image, and before we get to layout, we can scan the document and say, hey, let's get this image started sooner rather than later. But you can also do the same thing for your async scripts. Now, all of a sudden, if you've got your analytics script that your marketing team says, hey, this is really important, we need it loading sooner, you can go ahead and put an importance high on your analytics script and it will get loaded sooner. There is a hack, Malte has tweeted it out before, where if you use link-rel preload for scripts in combination with an async script, you can sort of fool the browser into thinking it's an important script, even though it's an async script. I would kind of prefer you sort of, if possible, stick with the priority hints rather than hacks. They'll tend to be more universally applicable. And then preloading, it's one of those, for the cases where the browser doesn't know the resources that you're going to want to load, or it won't discover the resources until it gets to layout, for example. Fonts is kind of one of those critical ones where the browser doesn't know what fonts you actually need until it gets to layout, at which point it's trying to draw the text, but it doesn't have the font to draw the text, and it goes out and does all the work to fetch the fonts. Preload's a really good case for that, where you can tell it, hey, but I know on this page you're going to need these fonts. Maybe start loading them so that they're ready. There are, I'll get to the caveats with preload in a minute. And that's sort of, at a high level, the priority decision and how you can influence and tell the browser what to order and what to load and when to load it. Things changed a little bit when HTTP2 became a thing. So before HTTP2, browsers would then take that priority information and they would have 6 connections per server-ish, and they would schedule those requests basically in priority order, and they would request 6 at a time and go, okay, let me pull the top 6 things that I need off for each server that I'm talking to, and I'll go ahead and fetch those 6 things. And then as it discovers new higher priority things, those will move up in the line. They'll wait until a slot opens up and the browser would fetch those resources. With HTTP2, the prioritization changed a little bit, where the browser still can make decisions about what the priority order should be, but there's a tree structure on each HTTP2 connection to the server. And the browser basically tells the server, deliver me all of these resources in this order, or with this. It's a little more than an order because it's got a scheme where you can balance bandwidth between resources at the same level in a tree. And so you can do things like say, I want to load this CSS, then this JS, and then these 3 images all at the same time, and then this other file. And so the HTTP2 priority scheme has a a very flexible tree structure that lets the client tell the server, this is how I want you to deliver everything, if possible. And it's a hint. The server still, if it doesn't have some of those resources, it doesn't just sit around and wait to avoid head-of-line blocking. It'll go ahead and send whatever it has. But it tries to stick as close to what the browser asked for as possible. And so in a waterfall, you tend to see this. These are two different web page test waterfalls, and I'm hoping the dark lines show up on the screen. Yes. Yeah, I wasn't sure about the contrast of the projector. So web page test now shows when each actual data chunk downloads. So you get a dark part of the waterfall bar when the data is actually downloading for that resource. So in the HTTP 1 case, you can see a bunch of open connections at the same time, talking all to the same server and downloading several different resources all at the same time, scripts and HTML in this case. And they're competing for bandwidth somewhat with each other. You don't get perfect serialization because you have 6 connections open at the same time, all downloading in parallel, but you're at least limited to those 6 connections per server. With HTTP 2, you get, and you see in the HTTP 1 waterfall, things are sort of stair-stepped and they're requested after previous things complete. With HTTP 2, you tend to have more of a wall than a waterfall, where everything starts at the same time and you have like really long times before things happen on some resources, but then the actual download time for each resource is supposed to be in the order that they were requested based on the priority. So in the case of the YouTube, like the third item down in the waterfall, it's the HTML. You can see the really dark bar. It's downloading first, and then the JavaScript that's down at the bottom of the waterfall is downloading next. And it's one of those things that we actually got a lot of, I've gotten so many pings by people going, it's a 6K file, how come it took 2 seconds to download? And it's one of those things where the HTTP 2 waterfalls are so much different from what you're used to looking at in HTTP 1, where you can't just look at the overall time it took for something to download, because it might be the lowest priority thing in the queue, and it's downloading everything else first. So make sure you're sort of looking at the context of the things downloading when you're looking at the waterfalls. But so in the HTTP 2 case, it's basically throw everything up to the server and pray that everything works out well. And this sort of praying, it's where I'm kind of about to shatter your illusion. And I'm sorry for that. I just kind of like to share my pain. And so preload. You have to be really, really, really careful with preload. We've seen cases, Andy, who's in the audience here, and I'm going to reference him way back and back. I'm going to reference him several times today. He had a client he was working with who was preloading a video file. Really bad idea. Chrome in particular has an issue right now where preloads end up getting a higher priority than most of the other resources in the page because they bypass some app cache logic, so they end up getting scheduled before like the critical resources in the head. And so this page was downloading the video file from the server before all of the blocking scripts and stuff in the head. And so you can imagine what that did for the user experience. It also, in this case, there were a bunch of fonts that were being preloaded, which is great. Get the fonts there so that they're ready by the time the layout's done. But unfortunately, because of the Chrome issue that Yoav is working on, hopefully he'll be able to fix soon, it was actually downloading the fonts before the CSS and before the JavaScript. And so the ordering there is not perfect. It delays render because none of that can happen. Might not be a bad thing if you want the first render to happen with the fonts. In the great scheme of things, it's not the perfect order. Optimally, you'd have the CSS and JS load, and then you'd have the fonts load. And so you can get your painting done and the text displayed quickly. But so be really, really careful. We have seen cases where people are basically like preloading every asset they have on the page. If the browser can discover it, don't preload it. If it's something that's in the markup, do not preload it. The browser's scanner will find it. It will try and do the best that it can with it. If it's a hidden resource, think really carefully if you want to preload it, knowing that it's not free. It's going to be competing with other resources on your page. And determine, is it critical to actually load that resource early or not? And prioritizing across connections. If you don't know what Thunderdome is, I'm sorry, we can't be friends. So it's the Wild West, it's Mad Max. There is no prioritizing across connections, either with HTTP 1 or HTTP 2. HTTP 2 works in an ideal world where all of your web page is delivered over one connection, optimally from one host. As soon as you involve a third party or a sharded domain or something that's not on that one connection, prioritization goes out the window. The resources for each connection are prioritized against other resources on that connection, but they're not prioritized against each other. So if you've got images loading on one connection and JavaScript loading on another connection and third-party remarketing tags loading on a third connection, those are all going to load at the same time and compete with each other. And that's not great for scheduling. And I used to sort of think of remarketing pixels as almost free. They tend to have like no bytes to them. They're like a tracking pixel that fires. Unfortunately, like at the bottom of the waterfall, you see the DNS socket connect. The purple part is the SSL negotiation. As we move to HTTPS, even 0-byte requests are far from free because the certificates tend to be on the orders of 6K. As we saw with the Hearst waterfall, I've seen way too many like that. They have like 11 requests that were theirs, and the rest, the vast majority of those are going to be advertising or remarketing pixels. Every one of those had a new connection. When you get 100 requests with 6K certificates each, you're talking 600K of data that's just in certificates for setting up all of those connections. And all of those are competing with your bytes for your JavaScript and for everything else that's on your page. So it's not quite free. You still want to schedule that stuff as late as possible if you don't want it to compete with your basic resources. And I'm sorry for going this deep into the networking stacks, but when you start competing against resources, against connections, it's not fair. You don't go, okay, I've got 3 connections, we're going to be downloading data, images, and JavaScript. It's going to evenly split the bandwidth between the two. Unfortunately, the TCP congestion control algorithms that sort of determine how the servers are going to send data down to the client, they don't all play well with each other. BBR is sort of the new hotness. It does really well for congested networks, for maximizing the amount of data that can be used from the server. When we turned it on at Cloudflare, I think we saw something like a 20% increase in the amount of data we were transmitting. And that's great because we're being able to saturate the links more. And it wasn't retransmits or anything, that was real data going out. The downside is it starves out the older congestion protocols. And so if you have a BBR connection going against an old school cubic or some other loss-based congestion protocol, the BBR, the current implementations of BBR will use 100% of the bandwidth and starve those out. And so Cloudflare uses BBR, Google uses BBR, Fastly has some experiments with BBR. And so you've got cases where if you're loading your resources from your origin and you've got third-party resources coming from Google or coming from a Cloudflare domain, those might actually completely starve out your resources. Connection coalescing. It's for HTTP2. I know yesterday we were talking a little bit about connection sharding for HTTP1. For HTTP2, we just talked about how multiple connections are really bad because you can't prioritize against each other. Well, a lot of companies have multiple domain names that they use. You've got like your image CDN, your JavaScript CDN, and it's just a lot of work to unwind all of that. If they all are on the same platform and they sort of all resolve to the same IP address and you've got the same name in the certificates, HTTP2, most browsers will coalesce all of those and go, okay, I know I have a connection open to a server that has a certificate for that same name as that other domain, and the DNS lookup for that other domain also maps to that. I'll go ahead and send the requests for that other domain over this same connection. So you can have all of your sharded domains collapse down onto a single connection. I say can because you still have to do the DNS lookups. There's no way to avoid that currently. There are talks in HTTP2 about ways to avoid that. So you're looking at least one round trip for each one of those sharded domains before it gets collapse to the original domain. If you're doing something like multi-CDN, you're playing with fire, because then you have to hope that all of those domains end up routed to the same multi-CDN under the covers and the same IP address to be able to coalesce. So honestly, if you can at all do it, stop sharding. It's evil. The easiest answer is, if everything is on your origin, then there's nothing that it has to do extra. It can just fetch everything. The other thing to watch out for that's font specific is, even if fonts are on a sharded domain that coalesces back to the origin domain, they won't go over the same connection. Because as far as the fonts are concerned, it's a different origin. And once fonts are on a different origin than the document, they get stuck in what we call anonymous connection hell, which in most Chrome and Firefox at least, cross-origin resources from CSS, which I think fonts seems to be like the only resources that fell in this spec hole at the time that people were like really worried about privacy. When they're not on the same origin as the document, they have to be on a separate connection pool that doesn't send cookies. So fonts will always sort of get their own connection independent of other static resources on a different domain. And so if you've sharded your fonts off onto a different domain than your origin, even if it coalesces to the same certificate, it's going to be on a separate connection and it's going to be competing. So fonts are a really, really important one if you can to get onto your origin domain. And so we've talked a bit about sort of what it looks like at a protocol implementation. The browsers can decide what the prioritization looks like, what that they advertise and ask for from the servers. Chrome, this is probably a little more tree-like than it really is in practice, but what Chrome does is it builds a linear list. It doesn't build a tree at all. It says, these are the resources I want, and I want them in this exact order. And it basically goes CSS first, fonts, as they're discovered, they're inserted up at the top of the tree, scripts follow that, and then images follow. It's not optimal. It's optimal for the CSS and script case, because we want those serialized in the order they're in the document. But for images, it's basically saying, give 100% of your bandwidth to each one of these images in this order. And so you get like an image loading completely and then the next image loading completely, and there's no concurrency going on. And that's sort of Chrome's model, everything in an explicit list order. Firefox sort of took the whole tree structure from HTTP2 and reimagined how it could do resource delivery, and it built virtual groups using the tree structure, and it tried to schedule things so that it'll load the CSS first, but it'll split bandwidth 66% to CSS, 30% to JavaScript. Within the CSS group and the JavaScript group, they all split bandwidth evenly, so you kind of get a weird situation where CSS and JavaScript are all downloading all at the same time, although they're weighted in such a way that the CSS is getting a little more weight than the JavaScript. But it's much better for the images, where you have the images all downloading after those, but concurrently. So you get some concurrency going on with the images. And so between Chrome and Firefox, you have like the optimal part for the scripts in Chrome and Firefox, and the optimal part in the images from Firefox. It'd be great if we could sort of merge the two together. When we get to Safari, it kind of looks like Safari stopped progressing on prioritization when Blink forked. And they have what looks like a model based on Speedy, where everything is attached to the root and everything downloads all at the same time with different weights. When it was Speedy, the weights actually meant an order, send things down in this order based on the priority. When it changed to HTTP2, those priorities became bandwidth sharing instead of an order. And so what you get with Safari is everything downloading all at the same time, but with bandwidth slightly favored towards CSS and JS and slightly reduced for images. But all of your images and all of your JS is all downloading all at the same time on Safari. At least that's what Safari is asking for. Edge, classic Edge anyway, and IE before it switched to Chromium, doesn't do prioritization at all. It doesn't send any priority frames. It sends all of the requests and says, give it to me. And the defaults in the HTTP2 spec are, when that happens, bandwidth is split evenly between everything, and everything is downloaded at the same time. And so that's actually strictly worse than the HTTP1 case, where you at least got 6 things at a time in sequence. Now it's your entire website downloads in parallel all at the same time, and then it sorts it out on the client whenever bytes arrive. So clients are all a little bit of all over the place. How do the servers look? So when I joined Cloudflare, one of the first things I wanted to do was make Google Fonts faster. It's one of those things, Google Fonts are on 60+% of websites, and they do a couple of things that are really, really painful. You load a CSS file from a Google Fonts domain, and that's 4 round trips to get that CSS just for the fonts, and that's render blocking. You can't render your page until you've done the additional 4 round trips to get the CSS from Google's server because it's CSS. And then that has the font definitions which come from a different server, so it's 4 more round trips to get the actual fonts. So you're looking at 8 round trips to get the fonts displayed on any page that uses Google Fonts. 4 of those actually block the render of your page. And so my idea, and I tackled it on my wife's blog first because, you know, I like living dangerously, was I'm going to inline the Google Fonts CSS so it doesn't have to do any external fetches that block render. And then I'm going to proxy the fonts themselves from the origin domain. So it doesn't have to do any additional round trips to set up a connection to Google Fonts, and it can just fetch the fonts over the same connection it's already got. And the other benefit that gets is it can in theory then be prioritized against all of the other resources on the page. Normally when you're using Google Fonts and it's coming on a separate connection, we get back into Thunderdome mode, right? By putting it onto the same connection as the origin, it can then get prioritized against all of the images and everything else that are going to be flying down at the same time, and it can reserve 100% of the bandwidth to the fonts. And so this is what happened when I did it. And for those of you that haven't looked at a lot of waterfalls, this isn't a waterfall. This is like a Rorschach diagram of some kind. And my start render went from, I don't know, it was 2 seconds, and it went to 9 seconds. And I had one of those, oh my God, how did I possibly break it this badly moments. And then that sort of evolved into, I didn't break it. Oh my God, how is Cloudflare broken this badly moments? At which point I had those life-questioning decisions of, oh my God, what have I done? But luckily, we have the technology. We can fix this. So yes, Cloudflare's HTTP2 prioritization was completely broken. As of August, I think it was, when I joined, you would get resources delivered in whatever order the edge happened to get them back from whatever backend it was talking to. So when it talked to the caches, you gave the Cloudflare edge, let's say 200 resources. If 50 of those were available in cache, for example, those 50 would be sent first, and then whatever came next would be sent, and it didn't care what order you asked for them in. You would get them in whatever order they happened to show up at the edge. And you get random waterfalls that started to look like this. We fixed it, and luckily, come October or so, things got a lot better. You start to see waterfalls that looked a lot more like what you would expect. And I was not questioning my life decisions quite as badly. And this is really what you want to see with an HTTP2 waterfall. A nice, clean, resources sort of delivered in priority order. The critical ones, your red ones are going to be your fonts, your green ones are your CSS, all of that like loading really early, and then your images sort of cascading after each other. And I was happy, the internet's good again. And then Zach Leatherman posted this in October and said, hey, guess what? I sharded my fonts off to a different domain and things got faster. And I started freaking out again. And it's like, oh God, I hope he's not on Cloudflare because I thought we fixed that. And I thought we were the only ones that had that problem. And it turns out he wasn't on Cloudflare and we weren't the only ones with that problem. So I worked with Andy Davies, again back there, And is HTTP 2 fast yet? .com, piggybacking on Ilya's, is TLS fast yet? We ran a test for all of the CDNs out there that we can recognize anyway, which is on the right. Some blurring to prevent the not so innocent right now, but less than half of the CDNs support prioritization. So this is our job, right? As a CDN, our job is to honor the protocols and deliver things that you ask for in the order, hopefully, that you ask for them, at least in optimal order. The good news is some of the really big ones are working well. Akamai, Cloudflare, now. Fastly, Facebook, Google, some servers work well, some don't. Not entirely sure what the distinction is between the GFE configs, but the ones you care about that serve your actual edge traffic do work. The ones that don't, that really freaked me out and that I am going to call out by name, Amazon, AWS. So I don't spend any, I spend $100 a month with AWS. They're not going to pay a lot of attention to me. But if you have an account with Amazon and you are using CloudFront or pretty much any of their edge serving infrastructure, check your HTTP2 prioritization, please. Ping your support contact and pressure them to fix it. And it's Amazon.com is also broken, so it's not just you, but they'll appreciate it, I'm sure. Google storage is sort of the one. There may be race conditions or issues going on with how the GFEs talk to the backends. The WordPress Jetpack CDN is having difficulty configuring. It turns out Nginx technically has prioritization implemented, but it doesn't actually work just because of how they pass buffers around. So you have to kind of watch out for, and if you've rolled your own HTTP2 deployment, my guess is you're going to have a big red X just because these are companies whose job it is to do this, and we're still having trouble getting it right. The odds are that your deployment, unless you're using H2O, H2O as a server makes it really hard not to do HTTP2 well. Unless you're using H2O, odds are your HTTP2 deployment is broken right now. When you're testing, I cannot stress this enough. HTTP2 testing, prioritization testing in general, do not use Chrome's DevTools connection profiler. It's great if you want to get a general feel for how your page loads under a given connection, but it does not work well for scheduling, prioritization, and things like that. Because of the level it runs at, it doesn't run at the packet level, it runs between the renderer and the networking stack. And so the resource prioritization decisions have already been made well before it gets to the scheduler. And so you won't be able to see what actually happens in a realistic networking condition. I saw a lot of Macs in the room. You've got network link conditioner built in with Xcode. That is an awesome tool for simulating network connections. Use that if you're going to be doing testing. And this goes for if you're doing lighthouse testing as well, or any CLI testing. Make sure you've got good traffic shaping running at a packet level, not sort of the built-in defaults that come with the dev tools. There's a Windows tool that I built that looks a lot like, well, it doesn't look like network link conditioner because I can't do UI, but it works a lot like network link conditioner. If you're on Linux, TC, NetM, you're used to command lines, that'll work well. There are good tools on all of the platforms for being able to do this. The other thing sort of to think about, and that's what we're starting to do at Cloudflare, is the prioritization is a request from the browser. Like we saw, none of them are actually doing it perfectly. Some of them are doing it very wrong. And so we're starting to ignore what the browsers are asking for and open up the opportunity for you to programmably decide what your prioritization should look like. Can you boost your own priority for your own hero images? Or we can apply our own sort of default logic that looks like, okay, we'll deliver the CSS and scripts in order, and then we'll parallelize the images and things like that. And so it'd be nice if your servers at least did something right with prioritization. We're trying to sort of take it a next step and hopefully do better than that. We'll see sort of where that ends up, but hopefully we can sort of evolve the the ecosystem for protocol level prioritization, at least. It's not all a complete dumpster fire, and I don't want to hopefully leave you here in despair right before you go to lunch. There are things you can do. A lot of the big CDNs are working correctly. Test your deployment, vote with your dollars, work with your CDN provider. If the prioritization isn't working, apply pressure. If that doesn't work, move. I mean, nothing will get them to fix it quicker than dollars disappearing. But it is critical. I mean, it is absolutely critical. You saw on my test page, I went from 2 seconds to 9 seconds start render because prioritization broke. It can make that much of a difference. Stop sharding, please. Stop sharding your content. The more you can have everything come from the same origin on the same connection, be prioritized against each other, the better off you're going to be. Third-party resources. Ryan's going to have an awesome talk later about all of this, but especially early in the load, try and minimize as much third-party content as you can. Those are going to be coming from different connections, different origins. You're not going to be able to prioritize or schedule any of those against your content. Priority hints, tell the browser what's important, what's not. Especially, it's particularly useful for boosting importance for images and async scripts right now. I wouldn't recommend you go and lower the priority for like a blocking script. That's not going to buy you anything beneficial. It'll just cause the browser to wait longer at that point. But boosting hero images, async scripts that you really care about is absolutely critical. I'm not sure how I feel about the last one, but if you really want to sort of avoid a lot of concurrency, hiding non-critical resources from the browser until you've at least gotten the critical stuff loaded. Lazy load images kind of falls into this camp. Maybe the native version of lazy load images is a better way to do that. I'm not sure how I feel in general about hiding things, but as a last resort, that might end up where you have to end up being if you're not able to sort of hold back the tide of things coming in. And that's it. So we're going to go from here to lunch. So if you've got any questions, I'm happy to chat, have a support group over lunch, something along those lines.